Bismillahirrahmanirrahim. In this short video clip, I will discuss the checkpoint 1. Before proceeding to this checkpoint, I will just skim through your book and comment what you can see. For example, in figure 22.6, you can see the electric field representation of a point charge Q, a positive charge. So the arrows, you can see the arrows represent the direction. The arrowhead represents the direction of the electric field, while the length of the arrow represents the strength of the electric field. So you can see at points which are closer to the charge, for example, these four points, red points, close to the source charge plus Q, you can see that the arrows are larger because a point closer to the charge will have a higher or stronger electric field. So the direction of the field is outward, and the strength is it's stronger. The field is stronger, so the length of the arrow is also larger. And when you move away from the charge, for example, in the next points which are a bit away from the charge, so you can still see that the field is pointing outward, as is always the case for positive charge. But you can see that the length of the arrow is now smaller because the point is a bit away from the charge, and so on. You can see for the outermost points, the length of the arrow is smaller than the two cases. So so the arrow associated with the point represent the strength of the field at that point, and also the direction of the field. So now come to the checkpoint 1. You can see here the checkpoint 1. They show a figure where a proton is placed at along the x-axis. So proton is represented by P, and electron is represented by E. The question is, what is the direction of the electric field due to the electron at point S and point R? So we had to find the direction of the electric field at point S and R. And the next question is then, what is the direction of the net electric field at point C, at point R, and then at point S? So we can, if you like, we can draw this here as well. For example, we can go to your presentation. No, it's not what I want to open. We can come to your presentation, PowerPoint presentation. I just opened it, completed a moment before. So we can make a copy of this, for example, slide. Copy, and then I can make paste, so that I should have an extra slide. Yes. Then I can draw, and I will select all what I have written so far on this slide. Yes, and then I will have to delete. I think I can delete this, or I can use this. Perhaps it's a bit stroke. No, I think again I can use this. Oh, sorry, delete is here. So once again, delete is here. Oh, come on, what are you doing here? You should also move. So now come to the video, and tool red, and this is checkpoint number 1. And what's the question? The question is that we have x-axis, and then we have a proton over here, P, and electron over here, E, and we have 2 points. Let's select another color, let's say black, and it's R point and S point. So the first question is in part A. If we come to the part A of the question, so the direction of the electric field due to electron due to electron at point S, and then at point R. So we can simply answer, if you remember that, remember the definition of the electric field, that the direction of the electric field. Electric field always point away from a positive charge, and it points towards a negative charge. So if we talk about, in the part A, we are talking about the electric field of an electron. So the electric field of electron will always be pointing towards electron. Okay, so if we say that the strength of the electric field, let's say I choose another color for not blank screen, but coming to the yeah, let's see this color, not blank screen but this one. So if we see, if we are if we are towards in the left region of the electron, so the electric field will always be like in this direction. Yeah, so we can say that this is pointing along the positive axis, or we can say that it's rightward because this is toward the right side. So at the position of the point S, the direction of the electric field is rightward, so I will write rightward, because the electric field of a negative charge is always towards the negative charge, or positive x-axis. If we want to draw the electric field in the right region of the electron, so it will always be again towards the electron. Okay, so the next part of this question is the direction of the electric field at point R. So B at point R. So point R, you can see that at point R the direction of the electric field is leftward. Yeah, I should use another color. I can use eraser to erase what I have written so far. No. Choose eraser. It is like this. Then I will choose red, and then I will write, no, not this one, but this one. So this will be leftward, or negative x, in the direction of the negative x-axis. Yeah, it's negative x-axis. So that's the answer. Now coming to the next part, C of the question, and the question is what is the direction of the net electric field at point R and then at point S. So net electric field, so for the net electric field, let me use another color to represent the yeah, just to show the direction of the electric field. So just color with this one to show the direction, and let's see, yeah, this color. So we can also represent the direction of the electric field due to proton, and proton is positively charged, so the electric field of proton will always be pointing away from the proton. So if we are looking in the region in the right to the proton, so it will always be pointing in this direction. I can write like electric field of proton if you want, and in the region left to the proton, it's in this direction. Yes. Yeah, so E electron. Now we have to find the net electric field at point R. So this is point R. Point R, you can see that point R is this one. So you can see that at point R the electric field due to electron is towards left, and at point R the electric field due to proton is also towards left. So if you add the two vectors which are pointing towards left, so it will result in a leftward vector. So we can write that leftward. The net electric field is leftward. I hope you understand this. Negative x-axis. If you are still confusing, then you can use like one vector is electric field of proton and another vector is electric field of electron, and if you add these two vectors, so according to head to tail rule, you will get this electric field. This is net electric field. Okay, so this is leftward. Now coming to the D part of this question, which says the net electric field at point S. We have to find the net electric field at point let me use another color to differentiate a bit from what we are doing at the moment. No, this is not tool. Let's see below. So the electric field, net electric field at this position now. So you can see that the electric field due to electron at point S is rightward, and the electric field due to proton at point S is according to the convention, it's away from the proton, so it's in this direction. So now they are pointing opposite. The electric field due to proton is leftward and due to electron is rightward. So these are two opposite vectors. Okay, so how we can find the direction now? Now look, that point S is closer to electron. You can draw the distance like this. This is the distance from the electron point S, but point S is very far from the proton. Okay, so the electric field strength depends on the distance as well, as you can see from the previous slide. So the electric field strength due to electron at point S is stronger than the electric field strength at point S due to proton. So I can represent like this, that the electric field vector is red due to proton. If I write like this is E proton, then the electric field strength due to electron at point S will be bigger, and it will be towards right. Now if you add these two vectors, you can see that the electric field due to electron is stronger, and hence the its effect will be stronger, and you will get a net effect which is in the right direction. So this will be rightward. Positive x-axis. So I hope this will be clear to you, how to find the electric field. You use the superposition principle. In case you have questions, so you can come to me via email or via KCMS. Yeah, and I would like to answer, and I will appreciate if you have some more questions regarding this lecture. So I hope this is for this 9th lecture of this course, and I will see you for the next lecture, lecture number 10. So yeah, so best wishes and see you.